Hello, everyone. We will start in just a few minutes. Um, so yeah, be right back. All right, it's 10 o'clock. Hello, everybody. Can everyone hear me okay? All right, fantastic. Welcome to the OMVCA spring training about mosquito identification and environmental surveillance for vector-borne diseases. And we can get started. There we go. All right. So, hello, I'm Danny Phillips. I'm a special project public health entomologist with the Ohio Department of Health. I've been here, this will be my third mosquito season. Started back, two seasons ago, and I've done a lot of the field work here in the lab, a lot of the mosquito identification. I've worked alongside Leanne Garrett, the head of the lab here at ODH Entomology Lab. And I graduated with my bachelor's in entomology from Ohio State University. And as I say, most bugs are cool, mosquitoes and ticks are not. So why do we do this environmental surveillance for vector-borne disease? Doing the surveillance helps predict disease outbreaks. There's usually a 2-week window between when West Nile virus positives pick up and human cases. We start seeing human cases. So if we are doing the surveillance and testing mosquitoes for vectors for diseases, once we start seeing an uptick in those, we can predict when more human cases will show up, and we can address the issue of applying pesticides or just communicating with the local health agency that submitted the mosquitoes to do some excuse me, sorry, and do some active measures towards that. Another reason why we do this environmental surveillance is it helps establish a baseline of where the vector species are distributed within Ohio. For example, Aedes albopictus, it's invasive, but it's established, and it's a secondary vector of Zika, dengue, and chikungunya. And although there is no local transmitted cases of these diseases in Ohio, um, collecting them and knowing where they're at helps us understand if we start to see human cases where there's a risk of getting a local transmission. And we also do this surveillance to help detect non-native species. So, for example, Aedes aegypti, very famous mosquito from the tropics, is the primary vector of Zika and dengue and yellow fever, chikungunya in the tropics. It's not established. It doesn't survive the Ohio winters, but as the climate changes, it's crucial that we do this sort of surveillance in order to see when if the mosquito were to appear, we have a better understanding of where to target our focus and apply active measures. So what pathogens are we testing for this year? In previous years, ODH tested mosquitoes for just West Nile virus, but this year we're doing a multiplex assay, and we're testing for a multitude of viruses that are spread by mosquitoes in Ohio. In addition to the West Nile virus, we're doing La Crosse and Eastern equine encephalitis, St. Louis encephalitis, and Jamestown Canyon virus. And it's important that we do this as a function of knowing when and where human cases could pop up. For example, last year in 2024, there was 14 human West Nile virus cases, which is pretty typical. And whereas the last outbreak year, we had 122 cases of West Nile virus in 2012. But this, not even close to the amount of Lyme disease cases that we have in Ohio. In 2022, there was 544 cases, and just 1 year later, there was 1,300 human cases of Lyme disease. But yeah. So the main part of this presentation today will be the mosquito morphology and identifying mosquitoes. So mosquitoes are insects, and they have the basic insect body plan of the head, thorax, and abdomen. And there are a lot of different and highly specific names for these body parts and body segments. But as we go through the presentation today, I will do a better job explaining using a dichotomous key, going through how to identify mosquitoes. One of the key features that, if as you're going through identifying mosquitoes, is identifying what is a male and a female. And those are pretty easy to differentiate. The males have very plumous antennae, whereas the females are usually much smaller. They don't have as much plumage on them. And males also have the clasps at the end of their abdomen, whereas females don't. And females are the only ones that take a blood meal, and they use this blood meal to develop eggs, and whereas males just drink nectar from flowers and do not take blood meals. So mosquitoes of public health significance, the most important mosquito here in Ohio is the Culex species, specifically Culex pipiens and restuans. These are the main vectors, primary vectors of West Nile virus. They also vector St. Louis encephalitis. And these mosquitoes are very happy in urban environments. They are container breeders. They breed in waste tires and storm drains and ditches. And they're distributed throughout Ohio. Very, very common mosquito. The other one of public health significance is the Aedes triceriatus, or the tree hole mosquito. This one is the vector of lacrosse virus, and this one is not as common, but still pretty prevalent throughout Ohio. This one, as the name suggests, likes to breed in tree holes. These are more often found in woods, whereas the Culex mosquitoes are found in your backyard, in almost anywhere. But these also are container breeders for the most part, and will lay eggs and spare tires and stuff as well. And then one of the other species of significance is Cocklotidia perturbans, the cattail mosquito. This one is a bridge vector for Tripoli, Eastern equine encephalitis, because the primary vector, the Culicida melanura, doesn't really bite humans or horses very readily. It almost exclusively feeds on birds. And but the perturbans will bite the infected bird and will be the bridge vector that can take the virus, the pathogen, the virus, and spread it to humans and horses. This one's not as common as even less common than the triceriatus and the Culex. This is a very specific kinds of habitats it likes, like more swampy marsh and damp forests. But and we have not very many cases of Tripoli. I don't think we've had a human or horse case over the past several years, but still something to look out for. And a lot of times mosquitoes, different insects are mistaken as mosquitoes. I know, at least personally, I get asked all the time, what is this big old mosquito? And it's a crane fly. But really, the defining characteristic of a mosquito compared to other flies is the long proboscis. You know, when you set a trap, you'll likely to find any of these listed here on the screen. But I'm from ODH Entomology Lab. We get sent all sorts of things claiming that they're mosquitoes, and they are not. All right. Now, enough of the slides. Let's transition to the microscope and let's look at some mosquitoes. Let's stop sharing, right? All right, can everybody hear me? All right. So identifying mosquitoes is fairly easy, especially when you have a dichotomous key to follow. The genus of the mosquitoes is the first step in identifying them. Also pretty easy to do. Let's take a look at in Aedes. There we go. Give me 1 second. There we go. Okay. See it all right? Sweet. All right. So this is an Aedes. This is an Aedes albopictus, to be more precise. This one is pretty easily identifiable because it is relatively small. It's very dark black, and the tips of the palps are white. And this one had, I don't know if it's very visible on here, but the scutum has one singular white line, very distinct. And let's get out. To go. There we are. All right. This is a Toxorhynchides, the elephant mosquito. At least using the dichotomous key, the first question it asks is the proboscis stout, tapered and strongly recurved, or is it uniform thickness and not strongly recurved? So this is an example of a recurved proboscis on the elephant mosquito right here. It's also extremely large compared to other mosquitoes. But the elephant mosquito is not very common. You won't find that in traps very frequently. But and I'll show you an Anopheles mosquito next. All right. Here is an example of Anopheles punctopenis. This one, oh geez. There we go. All right. So to tell Anopheles apart from other mosquito genus, the defining characteristic is the palps. So whereas the Aedes over here has very small palps, this one has palps as long as the proboscis. And then, not that one. Then we will go on to the next step, which will be if the mosquito has a rounded abdomen, end of the abdomen, or a pointed abdomen with the cerci extruded. Let's see here. Culex. So right here is an example of Culex pipiens. And I might need to zoom in better for this one. Excuse me while I focus. All right, so here is Pipiens. This is the Aedes albopictus we've been looking at. So if you look at the abdomens, I might need to. Notice how the abdomen of the Pipiens is rounded, whereas the Aedes is a little bit more pointed. Maybe not the best example. Let's find. Where's Japonicus? There we go. That one's a little beat up. There we go. There we go. Aedes japonicus. This one, you can see the abdomen, the tip of the abdomen is more pointed. However, Aedes are not the only ones that have pointed abdomens. I will show you the other genus that also has pointed abdomens here in a second. Clean up a little bit. There we go. All right, the other is Saurophora. And here's an example of Saurophora ferox. Also has the pointed abdomen. However, the defining characteristic between Aedes and Saurophora is the direction of the bands on the abdomen segments. The Saurophora have bands that are apical, which means towards the back end of the mosquito, and Aedes have basal bands, meaning towards the middle of the mosquito, towards the head. So here, here you will see, oh goodness. The bands, oh, this one's kind of beat up, but if you can see, oh, it's really saturated. Hang on. There we go. Mm-hmm. Sorry, trying to get the lighting here. All right. So the bands here are facing towards the end of the Ferox Saurophora mosquito, towards the butt, whereas the Japonicus here, oh my goodness, does not like that. The markings on the abdomen are towards the base, towards on the part of the abdomen that is closest to the thorax, the middle of the mosquito. Saurophora also can be distinguished because their legs. Oh, where'd you go? There we go. Saurophora can also be distinguished from Aedes because the scales on their legs are a lot more obvious, wider, fluffier legs. Put that away. We'll put that away. Next, with your mosquitoes, we'll go back to the mosquitoes with the rounded abdomens. So here is the pipiens again. Next, once you've gotten to this point on the dichotomous key, you would ask yourself, are there narrow lines on the scutum? And I will find the example of that. There we go. Not that one. So here is Orthomotopia signifera, which also has a round abdomen, final abdomen segment. However, on the top of the scutum, if you can see it clearly, this one looks kind of rubbed off. The top of the scutum has that. Oh, has the white lines that distinguish it from the other mosquito genera that have flattened abdominal the rounded abdominal segments. It's not really showing up well on the camera, but you can kind of see it. Very thin, very obvious white lines. And continuing on with our Culex right there, we'll look at the next genera with rounded abdomens. And right here is Cochlitidia perturbans. This is the other mosquito species of public health significance. This is the one that is the bridge vector for Eastern equine encephalitis. This one has its legs are gone, but oh goodness. But you can still see that it has the rounded abdomen, same as the Culex. However, this one has a banded proboscis. Oh goodness. There we go. Just does not want to focus. There we go. Okay. This one has the banded proboscis. And if it had legs, maybe I could find another one. If it had legs, you would see that it also has a noticeable band on the first tarsal segment. The tarsi is the foot of the mosquito. Maybe this one. Hind tarsi. Nope. That one does not have hind tarsi. Here's some. Here's a better example of the perturbans. So if the light focuses, you might be able to see that on this hind tarsal segment. There we go. On this hind tarsal segment, there is a band in the middle right there. The other distinguishing factor. All right. Now, still with our pipiens, our culex, we'll go to the next genera, which is Culicida. Culicida and pipiens are very similar to each other, or at least they look pretty similar. The differentiating, the key differentiating factor or morphological feature is that Culicida has spherical bristles. The spiracle of the mosquito is found on the abdomen. And it's pretty difficult to see clearly. Right here is the Culicida. This is an inornata, Culicida inornata. If I can get it to focus. The spherical should be right about here in the center of the thorax, and the spherical bristles, essentially hair CD, that are covering the spherical hole coming this way. The Culicida has this. The Culex and other genera do not. So that is the main factor. And the Culicida inornata is not super common in Ohio. We rarely ever get it, but they're a little bit larger than Culex for the most part. And so after going through the dichotomous key, you finally reached the last possible genera, which is Culex, which is our lone little pipiens here. So now we can go over a couple of the common mosquitoes that we might find here in Ohio in your traps. And we'll start with Anopheles first. So we already saw Punctopenis, but I'll bring Punctopenis back out. This is one of the most common mosquitoes that we get in our traps that are, non-Culex, along with Aedes japonicus. But this one is, not even on there. There we go. All right. Back to Punctopenis. All right. So this one is distinguishable because of the patch of scales on the side of the wing right here, the pale patch. It looks pretty similar to another species, Perplexans, but the Perplexan species, this patch of scales, pale scales on the side of the wing, is very small. This one is at least half as big as the black patch right here of scales. All right. I guess I could show you an example of that. Here we go. Okay. So right here is the Perplexans. And you can see that pale patch of scales on the side of the wing is a lot smaller compared to the punctopenis. If I can get it to, there we go. So yeah, punctopenis is a lot, the pale patch is a lot larger. The other Anopheles mosquito that we commonly get is Anopheles quadrimaculatus. Uh, this one doesn't have the pale patch of scales on the wings like the punctopenis does. The scales on the wings are all black. The scales on the proboscis and the palps in the body are all black. Pretty normal looking mosquito. And then another fairly common one that we get is Anopheles barbary. And this one commonly gets mistaken for Culex pipiens. But again, if you went through the dichotomous key, you'd see that these have the long palps, whereas the pipiens does not. The Culex does not. And these also have just more spindly, longer legs than the Culex do. But this one is, you tell this apart from the other Anopheles by it's smaller in size than most other Anopheles species, and it also has very bristly, long setae coming out of the thorax. Goes away. All right. And now we can go to Aedes. And following the dichotomous key, one of the first things it asks is, does the mosquito have banded legs or non-banded legs? And I'll give you an example of what exactly that looks like. There we go. So here is another Albopictus. The legs, as you can see, have the white bands at each end of the tarsal segments. It's blown around. Ooh. And an example of a mosquito without banded legs here with Aedes cinereus. The legs are one solid color. There's no band between each tarsal segment. Both of those, the cinereus and the Albopictus, are very common. We find those quite often. Uh, one of the, where did you go? All right. Hopefully this one has intact legs. Following the dichotomous key, this one has banded legs, but this one has bands on both ends of the tarsal segments, so on the top and the bottom. And this one's not super great. Or maybe this one. And we can zoom in. So if you can see it over here on this side, this is one of the segments of the tarsi, and you can see that there's a pale band on the top and bottom, making it almost like an elbow, a pale elbow. So this is Aedes canadensis, and this is of the mosquitoes that have that feature. This is the one that we see most common. And then we'll go to our most common non-Culex species that we at ODH receive, which is Aedes japonicus. This one is kind of similar to Albopictus, however, it's not as dark black. This is more of a dark brown. And oh, where'd you go? And on the top of the scutum, hopefully this one has it. It has golden lyre-shaped scales that make a lyre shape on the top of the scutum. That's one of the this one didn't really have it, but that's one of the difficult things about identifying some of these mosquitoes. Some of the characteristics are found on the scales, and especially the scales on the top of the scutum. Those often get rubbed off and removed in shipment or just being roughed around in the trap from the fan. But Japonicus is fairly easy to distinguish. And then some of the last mosquitoes that we have here in Ohio with banded legs. Also very common is Aedes vexans. Here we go. Here we go. Missing its head. However, Aedes vexans doesn't spread disease, but it's probably one of the most prolific biters. This is definitely a nuisance mosquito. If someone calls and complains about mosquitoes on their property, it's likely a vexans or a trivitatus. But this one has really narrow bands. It's pretty easy to identify because of that feature, narrow bands on the legs. And additionally, if this one has it, there we go. So these are the bands across the abdomen or the abdominal segments. And this is the only mosquito with the feature of having the notch in the band across the abdomen like that. So pretty easy to tell apart. All right. And now we'll go to the Aedes with outbanded legs. This was, like I said, one of the first questions at the beginning of the dichotomous key for this genus, banded or no banded legs. So here, focus. Here is an example of Aedes trivitatus. This one, like I said, is another very prolific biter. Same sort of thing. If someone calls and complains about mosquitoes on their property, it is likely this is one of the culprits. Very aggressive biters. But this one is identifiable because it doesn't through the there's no bands that go across the back of the abdominal segments. Um, it does have markings on the side though here, these triangle shapes, very distinct. And it's usually a good how we pick these out. Or what else? Put that back. We can bring out the Cinereus again, wherever that went. There we go. So here is the Cinereus once again. 80 Cinereus doesn't have the banded legs. It also doesn't really have any markings on the scutum. Let me get it. There we go. Not really showing the scutum. If you can see, there's not any distinguishable markings on the scutum. It's all one uniform color. And it does have bands that go across the back of the abdomen segments. This one's pretty common. Now we'll go to one of the last 80 species that we get pretty often, but this is also the this is also the other species of public health significance in Ohio, Aedes triceriatus. Same thing at this point in the key. There's no bands on the legs. This one is a dark body with silvery scales, but the defining feature on this one is this flattened segment at the very end of the abdomen, the last segment of the abdomen. It's flattened, it's yellow, and as I said before, Aedes triceriatus is the primary vector of lacrosse virus, which Ohio is one of the leading states with human cases of lacrosse. Oh, and probably doesn't have it, doesn't show it, but the top of the abdomen should have one dark stripe down the middle, surrounded by two white stripes on either side, or a white stripe on either side. All right. So that was most of the Aedes that we find here in Ohio. Well, we'll move on to Culex. So we'll go back to Pipiens. There we go. Here's an example of Culex pipiens. You know, gone through the key to get to the genus. We figured out it's Culex. This Culex pipiens has bands that go across the abdomen, and they're usually in a half semicircle, arced shape. And other than that, it's a pretty normal looking mosquito. It's just brown and boring. But this is the one that spreads West Nile virus in Ohio. It also spreads St. Louis encephalitis. Um, and this is responsible for, biting a reservoir host like a bird, and it'll take if once the female bites a human, it can infect the human with West Nile virus or the horse. And the Culex pipiens looks really, really similar to Culex restuans, which I don't think we have any examples of, but because they look so similar and they both can vector the disease, we'll, when identifying here in the lab, we'll just call it Culex species, and we'll save both. One of the other species of Culex that we get is Culex territans, which I have an example here. Sort of. All right, Culex territans. It's a smaller, darker mosquito than the others in the genus. But this one also has dark scales that go across the underside of the abdomen. Oops. If we can focus in on it. There. Yeah. So it has the dark scales that go across the bottom of on the underside of the mosquito across the abdomen. And one more that we get. Oh, excuse me. I thought I grabbed the wrong one. Let's go back to territans. So territans, Culex territans, I couldn't really see very well on the microscope, but this one, rather than having the dark scales, it has bands on the dorsal side of the abdomen. However, these ones are apical, meaning that they are on the side of the segment towards the end of the mosquito. So I don't know if you can see it very clearly, but that little white, the other side, small, narrow white bands that go across the other end of the abdominal segment on the apical side towards the butt. All right, now we'll go to the one I was describing before. So here is Culex erraticus. Blowing around. This one, as I was describing before, is smaller, darker than the other mosquito species, or the Culex species. And this one has, where'd you go? This one has dark scales across the bottom of the abdomen. It's right there. There you go. So on the underside of the mosquito, across the bottom of the abdominal segments, this one has dark scales. It also has a patch of light scales on the mesoploron, I believe, the side of the mosquito on the thorax. Not picking it up super well, but small patch of pale white scales. We already looked over the Culicida. Now we'll go to the Saurophora. And Saurophora are pretty easy to tell apart from the other genus because they're a lot more colorful. Most are even iridescent. So, for example, bring the Ferox back out. So the colors aren't showing up super well on here, but Ferox is like almost like iridescent purple. It's got some gold in there. And one of the key features of this one is it has white. The last few segments of the tarsi are white, as you can see. Jeez. Right here. The rest of the leg is a dark iridescent purple. And then the top of the scutum has, if this one had it, scattered golden scales. Uh, one of the species of Saurophora that we get that I still get confused with sometimes is Columbiae. This one looks really similar to a species of Aedes because it has scattered pale scales all over the body. However, you can tell this from other Saurophora species by the band on the tibia of the leg. Little thin band. Kind of hard to. There we go. Right about there. And Saurophora also has some pretty large mosquitoes as well. This one's not very common at all, but it's Saurophora ciliata, and it's pretty big. Also pretty colorful, but you know, after using the dichotomous key to get to this point, you'll notice that if this had its legs still, you'll notice that it has very plumous legs. The scales on the legs are very, large and broad and fluffy. And this one's also pretty colorful, but yeah, very, very not common. We don't get these very often. And when we do, they're usually in pretty rough shape because they're so big compared to other mosquitoes. They get banged around quite a bit. All right. And we can look at some of those not as common genera, like, oh, where'd you go? Here is, oh, these are the males. There we go. Here is Urinotania sapphirina. This one, without the microscope, looks pretty similar to what a Culex might or a Anopheles barberi might, but if we can get it to show up, this one has signature iridescence, blue iridescence on its body and wings. Possibly. If it would show up, it's on the side of the thorax there and on the top. It also has the proboscis is flared at the end. It's kind of clubbed. I don't know if you can see as it dances around. But yeah, um, that's most of the species that we find here in Ohio. There are every once in a while we'll get some more uncommon, rare species, but definitely using the dichotomous key, if you have one available, is the easiest way to identify mosquitoes. And if you're, a local health agency or a environmental health specialist or, someone that's trapping mosquitoes for the purpose of doing pathogen testing, if you're in doubt, just send it to ODH entomology lab, and we can identify it for you. But now we will switch back to the slides, a few more of those, and I have one last thing to do with the camera, and we'll go from there. All right. Oh, there we go. So yeah, like I said, here is a quick reference guide to the genuses of some of the genuses of mosquitoes that we have here. So to trap these mosquitoes, there are a couple different types of traps that we use here at ODH. One of the principal trap that we use is the gravid trap. This is the most effective at collecting gravid, blood-fed Culex mosquitoes. It's also pretty good at getting some Aedes species, but we use this for our West Nile virus surveillance. and a lot of other health agencies use this kind of trap for West Nile virus surveillance. If you're unfamiliar with the trap, it's essentially a basin with mosquito brew, is what we call it, gravid water. Essentially, it's fermented grass clippings, plant debris, a little bit of yeast and protein to make it more nutritional or attractive for the culex to come lay their eggs. Which is what they do. The females that have had a blood meal had a chance to bite a host, and are ready to lay eggs will come to the trap, and they will attempt to lay on top of the water and lay their eggs. But the fan pictured, the fan in the net pictured in the middle of the trap there, will suck it up, and this kind of trap will collect hundreds of mosquitoes over the course of a night if in a good area where there's a lot of mosquitoes. Then another type of mosquito trap that's commonly used is a sentinel trap. This one is best at attracting and collecting Aedes mosquitoes and some culex. This one is not preferred simply because we could be collecting mosquitoes that have not had a blood meal yet, that haven't had a chance to pick up any pathogens from or viruses from other hosts. But how this one works, we'll use a little cooler of dry ice for our CO2 lure, and we'll also use a scented lure that has the same sort of like volatile skin compounds that you give off, or that a mammal would give off, that is attracting to host-seeking mosquitoes. And they'll be attracted to that. They'll come to investigate, looking for a blood meal, and they'll get sucked into the hole in the middle by a fan. And then one of the most general light traps that we use is a light trap. This is not particularly good at catching, anything besides the cockatrice perturbans. It's good at like getting the species diversity in the area, because a lot of insects are attracted to light. But same sort of deal as the sentinel trap. We'll use a cooler with CO2 as an attractant, or dry ice for CO2 attractant. And all these traps, you can leave them out over the course of a night and then come and collect them the next day. Okay. So as a reminder, ODH's environmental surveillance for West Nile and vector-borne diseases has begun. And we are currently accepting mosquitoes from local health agencies, universities, and we will continue to be accepting samples of mosquitoes until the end of the summer, around fall, sometime in fall. We don't know quite yet a final date, but we do have some changes this year to how we will be running the PCR tests. This year, mosquito pools will be a minimum of 5. And like I said, it's a multiplex assay this year. So we'll be testing the Triceriatus and the Cockatidia perturbans along with the Culex species that we collect or that are sent to us. And if you want to start doing your own collecting, it is recommended that you have at least 4 locations throughout your jurisdiction, and at a minimum, you go and collect mosquitoes every 2 weeks, preferably every week. And then make sure that you send all mosquitoes that you collect. And if you're still unsure about the identification, or if you don't have the materials to identify them yourself, just send us everything that you collect. And it's also really important that you provide as accurate like environmental data of the weather, the location, the habitat type, as accurate as you can possibly get it. And then, oh yeah, when packing the mosquitoes, please try not to have any more than 50 mosquitoes per tube. And then make sure that the tubes of mosquitoes are labeled and numbered with how many tubes per trap or per location. And so now we will switch over to the camera and I will show you how to prepare, pack, and submit samples to ODH. All right, hello. Hopefully everyone can still hear me. So uh, we've already sent out to all the agencies participating. We've already sent out coolers, and this is an example of the kind of cooler that you get. Oh, here, let me see if I can change the background. There we go. Okay. This is an example of the kind of cooler that you would get. Make sure that you use the cooler that we send you. We've already gotten some agencies that have sent back coolers without a box around it, and that incurs an extra $25 charge on the additional shipping and handling. So please use the materials that are provided. But so you'll receive a cooler like this. Inside of that, you should have ice packs, plenty, and you'll have the bag of bags, a Ziploc bag with smaller bags for your samples. You'll also have another bag for the field record. The initial cooler should be sent with label tubes, or tube labels, and you'll also you should have received an email with all of the paperwork that we would need whenever you send in mosquitoes and how to pack them as well. But like I said, the tubes, no more than 50 per tube, if possible. And you're also more than welcome to send in any ticks that your agency might have uh, found while out doing the environmental surveillance. Either send that paper in the cooler with it, but you have your field record in the bag. And then all the or in each per day that they were collected. And then the paper can go right into the cooler with the ice packs. The bag with tubes can go in there. And you should have already received a couple 4 or 5 shipping labels for us. If you need more, please contact me or the zoonosis at odh@ohio.gov, and we can get you more shipping labels. You can also request more materials. But yeah, I think that's it. Let's see. Pick up and move. All right. So that is all I have for you today. If anyone has any questions, please feel free to type in the chat or unmute yourself. Which month is the worst for mosquitoes? I would definitely say like late summer, in August, September, I think is when it's worst for mosquitoes. That's when most of the nuisance mosquitoes are out as well. For anyone that needs a key for identifying mosquitoes, please contact me at or Leanne at ODH. We have some extra copies of the dichotomous key of mosquitoes in the eastern United States. For those who want to identify their own mosquitoes. Hmm. All right. Well, if that is it, I really appreciate everyone showing up today. I hope that I could explain a little bit for you. That is a little informational, and like I said, please contact me if you have any questions or concerns, or if you're a local health agency that has issues with collecting mosquitoes. I can give you tips and tricks on at least what we do at ODH to increase your yield, I guess. But that'll be it. Thank you for coming.